balance chemical equations using something called particle diagrams that we may remember from this year. So let's look at a chemical equation here. A chemical equation represents a chemical reaction. So I'm going to write that here as like a little vocabulary. Represents a chemical reaction. And so we have 6 CO2 plus 6 H2O yields, which is this arrow, produces C6H12O6 plus 6O2. Now, on the left side, before the yield arrow, before the reaction arrow, are the reactants. We start with them. On the right side, what we make, we end with, or we produce, or make products. Now, there are these numbers that go in front of each substance, like the 6 CO2. It says it's the number of molecules. We call this a coefficient. And that's what we're going to use to conserve matter and balance a chemical equation. So there's a 6 coefficient here, a 6 here. There's none here. When there is none, you assume it is 1, and then there's a 6 here. And then you may remember from a previous unit or topic, that little 2 right here, that subscript, that tells me the number of each atom found within a molecule. So just kind of reading and interpreting an equation here for us. Of course, we could include states of matter, where S represents solid, L represents liquid, G represents gas, AQ represents aqueous. So if you ever see those states anywhere, those are just a state of matter. It doesn't really affect the balancing. It just tells you whether you have a solid, liquid, gas, or something aqueous involved. All right, so let's look at other balanced chemical equations and how we got there. So the first 2 questions here, or the first 2 equations here, are already what we call balanced. Balanced means we have an equal number of atoms on both sides of the reaction. So let's see how we got that with these numbers. And this is what's called balancing an equation. So we have 2H2 plus 1O2 yields 2H2O. I find it best to draw circles or particles to represent each of the atoms and molecules. So it says I have H2 here. Let's represent H2 with 2 blue circles. It says that there should be 2 H2, so that means I'll have 2 sets of those 2 blue circles. Then it says I have plus 1 O2. I'll make O2 a bigger connected circle, that's O2. And I get 2 H2O. Well, I represented an H with a blue circle, and I represented an O with a black circle. If I want to do H2O, there are 2 H's and 1 O. So I'm going to have 1 O, 2 H's. This is H2O. That coefficient in front, that 2, tells me that there are 2 of them. So I'm going to make another one here. Now let's count and see if or how we have equal numbers of atoms on both sides. The only types of elements or atoms that we have here, we have to keep account for are H and O. So let's look at H and O from the left side and the right side here. On the left side, I have 1, 2, 3, 4 H's. On the right side, well, look at that. I have 1, 2, 3. I also have 4 H's. For oxygen, on the left side, I have 1, 2 O's. On the right side, I have also 1, 2 O's. This is balanced. So this is what you are looking for, or how I could tell whether or not I have a balanced chemical equation. Let's look at the next one to see how the equation, or if the equation, is balanced. So we got H2 again, and it's just 1 H2 plus 1 Cl2 gives me 2 HCl. I'm going to draw H2 like this. This time I'll draw Cl2 like this, going a little bit faster here. And I'm making 2 HCl. Let's see if this is balanced. And I could already tell in counting it is. I have 2 H's, 2 Cl's, and look at that. I have 2 H's and 2 Cl's. These equations are balanced. Now, how do you balance an equation if not already given these coefficients? And that's what we're going to do in questions 3 and 4. So for 3, and 4, I always like to start out by drawing each of the particles given in the equation. So we have Na on the left side, which I'll make a purple circle. We have O2. I'll make O2 two connected red circles, because it's each O. And then I get Na2O. So that's one O with two NAs. Now we're going to begin to balance this equation. The way that we balance is by adding particles to the side that is missing or lacking and continuing to do that back and forth. So if I look at this right now, I have one Na over here, but I have two NAs over here. I need to add another Na onto the left side. And in doing that, boom, my NAs now, I have equal amounts. That's good. Let's see if there's another atom that is not in equal amounts on both sides. Well, I have two O's on the left side of the reaction arrow, but I only have one O on this side. Okay, well, in order for me to get more O's on the right side, I can't just add an O. I can't just do that because I don't have anything in the chemical equation that just has an O. I need to add an O with two NAs. This is how I'm balancing. I have to add to the side that's lacking. And so now I have two oxygens on the right, and I'm good here. But notice how, now I have too many NAs. I have 1, 2, 3, 4 NAs, but only 2 on the right. That's an easy fix. I just got to add 2 more and call it a day. And now my reaction is balanced. I have an equal number of atoms on both sides, and I'm ready to put coefficients in. I needed 4 NAs. I only have one O2, and I make 2 Na2Os. This is balanced. Also, my coefficients of 4 to 1 to 2, they cannot be simplified further. Like I cannot divide by a common number. So that's how I also know that this is balanced correctly. Let's try one more, and then you could do the rest on your own. Let's look at this next equation. N2 plus H2 yields NH3. So I have N2, I'll represent that with 2 doubled up circles. I have H2, I'll represent that also with 2 double up circles. My NH3, N, I represent by a blue circle. H, I'm going to represent by a black circle. And if you didn't keep track of me with a key here, I'll make this N and this H. I was trying to be consistent with my size or my color of circles. So I have N2 and H2 and H3. I could see that there are too many H's on the right side and not enough on the left side. I need more H's on the left side of this reaction arrow. The only way that I could add H's is I cannot do this. I know that, that'd be easy done, I have 3. There is nothing that says plus H over here. There is nothing in that reaction that says plus H. I need H2, so I gotta double this here. So I gotta go 1, 2. Now I have 4 H's over here, and I gotta go back to the other side. This only has 3. I need more on this side. And again, it would be nice if I could just do this, but I cannot just add an H. There's nothing over here that says plus H. It's NH3 on the right side. So I have to add an NH3. So I'm going to add another NH3. And now I have 6 H's on this side. On the left, I got to go back to the left side. I only have 4. And look, the math is going to work out here. I just need one more little H2. And now my H's are good. And also, would you look at that? That was very nice that we focused on the H's because our N's are balanced. We have 2 N's, we have 2 N's. We're good. We are ready to put our coefficients in then. I only needed 1 N2. I needed 3 H2s to balance this equation. And I made 2 NH3. And 1 to 3 to 2 cannot be simplified. So we are good here. All right, to check on with your practice, you are going to want to try and do questions 5 through 9. Once you do 5 through 9 and balancing, you're going to then answer the analysis questions about balancing a chemical reaction and what's involved with the atoms and the molecules. If you have any